Welcome to You Can Do It Math. Today we're doing the 2021 May-June paper 42. Question 1a. A 2.5 litre tin of paint costs $13.50. In a sale, the cost is reduced by 14%. Now remember, when we reduce a amount by 40%, we start off with 100%. And then we subtract 14%, which means we'll end up with 86%. Or as a decimal or multiplier, that's 0.86. So all we need to do in this question is multiply 13.50 by 0.86, and we get the price of $11.61. Do not round this to three significant figures. It's money. Write it to the two decimal places. Question 1a, part 2. Work out the cost of buying 42.5 liters of paint at this sales price. Okay, so first of all, remember that 1 tin is 2.5 liters. So first we need to work out how many tins we need to buy, and that will be 17 tins. Now we're buying them not at the original price, but we're buying them at the sale price. So we need to take our answer from the previous question. 17 tins times 11.61 gives us $197.37. Do not round this to three significant figures. It's money. Write it to two decimal places. Question 1b. Henry buys some paint in the ratio red, white, green, 2 to 85. Find the percentage of the paints that is white. So looking at that ratio, if he buys 2 liters of red paint, he buys 8 liters of white and 5 of green. So altogether, that would be 15 liters of paint. Okay. Now to work something as a percentage, we need the total, which we now know, 15, and then the amount of the specific value we want. In this case, it's white paint. The white paint is the middle value in the ratio, so that's 8 over 15, and this being a percentage, we times it by 100. So that's 8 divided by 15 times 100, 53.3 recurring percent. Okay. You don't have to put the recurring dot, but we're being thorough. Henry buys a total of 22.5 liters of paint. Find the number of liters of green paint he buys. So we know already the ratio gives us a total of 15 liters. Okay, but he doesn't buy 15 liters, he buys a bit more than that. Okay, so to find the multiplier, the amount that he buys more, we need to divide 22.5 divided by 15. So he buys 1.5 times the amount the ratio gives us. So that means to find the amount of liters of green paint he buys, we need to increase it from the ratio by 1.5. So remember now, green paint is the last value in the ratio. We need to increase 5 by 1.5, which will give us 7.5 liters. Question 1c. According to the examiner's report, lots of students struggle with this question. So we're going to look at this very thoroughly. Maria paints a rectangular wall. Let's make ourselves a little diagram. Okay, there is a rectangular wall. The length is 20.5 meters. The height is 2.4 meters. Correct to one decimal place. This is important. Okay, the moment you read that correct to one decimal place, it means we're working with bounds. It means that 20.5 and 2.5 meters has been rounded. Okay, now correct to one decimal place. The best method here is to take the value that has been correct to, which in this case is one decimal place, which means 0.1, and divided by 2, which gives us 0.05. We now need to work out bounds. Okay, I'm going to work out everything so everything is clear. So for 20.5, the lower bound will be 20.5 minus 0.05, which is 20.45. That is the lowest value. The shortest length that wall could be long, right? And then there's the upper bound. We're going to add the 0.05, which is 20.55. So that means the wall can be up to 20.55 meters long. Do the same with the 2.4. The lower bound will be 2.4 minus 0.05, which is 2.35. And the upper bound, we add the 0.5, which is 2.45 again. So the height of the wall is somewhere between 2.35 and 2.45 meters. Okay, let's move on to the next part. Right, 1 liter of paint covers an area of exactly 10 meters square. So first we need to work out the area of this wall. Okay, now it could be different values. So again, upper and lower bounds. The lower bound of the wall will be the smallest two values multiplied together. So that will be 20.45 times 2.35, which gives us 48.0575 meters square. Okay, so that is the smallest possible area for that wall. The upper bound, how big can that wall be? 20.55 times 2.45. We take our two biggest values, and that will be 50.3475 meters. So that is the largest wall could possibly be. Okay, now each 1 liter covers 10 meters square. So if we divide this by 10, we will know how many liters of paint we need. So let's do that for each one of those. So for the lower bound, 48.0575 divided by 10 means we will require 4.80575. You see, no rounding here yet because we're not finished. Don't round your answers until the very end. So that will require 4.8 etc. liters of paint. But if the wall is its biggest possible value, okay, we will need more than 5 liters of paint, slightly more. Calculate the smallest number of 2.5 liters tons of paint you will need to be sure. I think this is the most important part. To be sure all the wall is painted. That smallest number can be confusing. Okay, and that's why I'm working out both the upper and the lower bound so we can very clearly see which answer is going to be correct. So we need somewhere between 4.8 etc. and 5 point something liters of paint. To work out how many tons we need to buy at 2.5 liters a ton, we need to divide. Okay, so 4.80575 divided by 2.5 gives us 1.9223 tons of paint. All right, so that looks like a possible answer. She's gonna need slightly less than 2 liters of paint. But let's do the other one. Okay, so we got, what's the other one? 5.03475 divided by 2.5. So if the wall is the biggest possible value, we're going to need 2.0139 tons of paint. Okay, this is now where we need to think carefully. Okay, she wants to be sure. This is why I said this, to be sure is the most important part, that she has enough paint to cover the wall. So we are not going to use the lowest value here. Okay, because if the wall is the biggest it could possibly be, we are going to need to buy the maximum amount of tons of paint, which is this one. Okay, because she wants to be sure. And that's 2.013 tons of paint. Now, if she buys 2 tons of paint, is that going to be enough? No. because there's that 0.0139, which is more than 2. So she's going to have to buy a third tin of paint. She's just going to use a little bit of the paint because 0.0139 is very little, but she's going to need that little bit, and she's going to have almost a full tin of paint left in the cupboard, which she's not going to use. Okay, so the amount she needs to buy is 3. All right. Yes, I've done way too much calculations here. You don't have to do all of it. The important calculations here was finding the upper bound. Okay, the upper bound of the lengths, working out the upper bound value, working out the most liters of possible paint, working out the biggest amount of tins, and then getting 3. Okay, so you don't have to do all that working out, but it helps to get a clear picture and a clear answer. Working out the upper and the lower bounds is helpful. Question 2, let's start by completing the table. So we put the equation 2 times 0.5 to the power of x. So we press this power button, and the first value we need to put in there is 0. Use the arrows, -1, and press equal, and we get a value of 1. Next, we need to put in the value of 2 into the equation, so we can just go back and put, instead of the 0, put a 2 and press the equal, which gives us -0.5 or 0.5. Okay, next would be to plot the points. Right, plotting the points, -1, 3 along the corridor up the stairs, -0.5, 1.83, there we go, 0, 1, 0.5, 0.4, not quite right, is it? 0.5, 0.41, 1, 0, 1.5, negative 0.29, 2 minus 0.5. Right, connect these with a smooth curve, a sharp pencil, not a ruler. Make sure you go through every point. Question 2b, a bit of a harder question. Lots of students struggled with this. Okay, so let's start very slowly. Let's write down the equation they've given us. They've given us 2 times 0.5x plus 2x minus 3.5 equals 0. Okay. All right. Now we need to use the graph we have already. And the graph we have already is this one we've just drawn. And there it is. It's the graph of y equals 2 times 0.5x minus 1. So I'm going to write that down just underneath here. So we have 2 times 0.5 to the power x minus 1. And that's equal to y. Okay, so how do we get from the one to the other one? How do we get from this graph to that graph? This is important. Okay, first of all, we need to get rid of this 2x. So we subtract it. And in any equation, what we do on the left, we have to do on the right. So we need to subtract 2x from that side as well to keep it equal. Okay, how do we get from minus 3.5 to minus 1? We need to add 2.5. So minus 3.5 plus 2.5 gives me minus 1. What we do on the left, we have to do on the right. Okay, so over here now, we've made them equal. We got 2 times 0.5x minus 1 equals this. Okay, my two equations is now equal. So that means I've got an equation of y equals minus 2x plus 2.5. And as you can see, that is the equation for a straight line which they want us to draw. So on the graph above, we're going to draw a straight line, y equals minus 2x plus 5. What is that line going to look like? Well, the quickest way is to find the x and the y intercept. Now, for the y-intercept, we can make x 0 because on the y-intercept the x value is 0. So that will give us y equals 2 minus 2, by the way, times 0 plus 2.5. 0 times minus 2 is 0. So that means y equals 2.5. That means our straight line is going to go through 2.5, 2.5 on the y-axis. Okay. To see where it crosses the y-axis, we make y 0. So that will give us 0 equals negative 2x plus 2.5. Let's solve that. Subtract 2.5 from both sides. So that gives us minus 2.5 equals minus 2x. So x equals negative 2.5 divided by negative 2. So my x-axis interval will be 2 negatives makes a positive. 2.5 divided by 2 is 1.25. So we now know it will cross the x-axis of 1.25, which is over here, halfway between 1 and 1.5. We now have 2 points, 2 intervals on of our graph, and we can draw a straight line. And so let's do that as accurately as possible with a ruler and a sharp pencil. Okay, so what's next? Say by drawing a suitable straight, solve the equation. Okay, now that's solving simultaneous equations. We've got 2 equations. The solution is where the 2 graphs cross. So meaning this is where my solution is. So I just need to go from there to the x line. So we got x equals, okay, look carefully at the intervals on this axis. Each 2 squares counts for 0.1. So this will be 1.4. So x equals 1.4. On the mark scheme, they allow you anything from 1.3 to 1.4. So I got mine correct. Okay, very good. So look carefully. Yeah, you get a mark for recognizing the equation. You get a mark for drawing a straight line correctly, and then for reading out the correct value. Question 2c, there are no solutions to the equation, and that's the equation we've just drawn, equal to k. So what is k doing there? Let's see. On our original equation, all of this was equal to y. Now they've got all of it equal to k. So what we're looking at here is what is y is basically equal to k. They are the same thing. Where k is an integer, remember integer means whole number, no decimal values. Okay, 1, 2, 3, 4, 5 or something negative. Complete the following statements. The highest possible value of k is. So, like I said, k is equal to y, meaning that, let's get a color here, that if I draw a line through the y-axis, for example here, okay, there we go, that's the line y equals 1. I have one solution there, which is y equals 0, x equals 0, because the 2 lines cross. Okay, now where do I have no solution? Then the answer is down here. Okay, if I were to draw a line here, if I were to draw a line here, okay, remember we're only looking at the original graph, not the straight line we draw in question 2b. Okay, these 2 lines doesn't cross. This is the highest integer, lowest and highest integer, where if I draw a line, there's no solution. And this is the line y equals minus 1. Okay. The next integer, of course, will be y equals 0, where it will cross. The 2 graphs will cross. Okay. So the highest possible value for k is negative 1. The equation of the asymptote to the graph is, okay, asymptote, what does that mean? It means a line that's being approached in a graph but never reaches it. Okay, let me show you what it looks like on Desmos graphing. So if we go here, so here I got the same two graphs. This is the in red is the graph we just drawn ourselves, and in blue is the one I drew in green. And as you can see, these lines, they get closer and closer, they approach each other, and even though it looks like they're gonna touch up to infinity, they get infinitely closer to each other, but they will never touch each other. Okay, and that's the definition of an asymptote. So here we go. So the equation of that line is what we already written down, y equals -1. Question 3, we're doing indices. Remember your laws of indices. When we multiply two numbers, base numbers are the same, we need to add the indices. So the first one there is 7 to the power of 11. Okay, if we are dividing with indices, we need to subtract, so that's 7 to the power of 10. Okay, and the last one, 42 plus 7 is 49. We need to write it as a single power of 7, which means we need to write 7 to the power of something, and of course 7 squared. 7 times 7 is 49. Easy one there. 3b, simplify. Okay, everything inside the brackets is being cubed. That means we need to do 5 cubed x squared cubed to a power that we need to multiply together. Then it's times 2 is being cubed, x is being cubed, and y to the power of 4 is being cubed. So let's do that. 5 times 5 times 5 is what? 125. X to the power of 2 times 3 is x to the power of 6. 2 cubed, 2 times 2 times 2 is 8. X cubed, and y to the power of 4 times 3 is y to the power of 12. Okay, we can still simplify this more. We do 8 times 125 is of course 1000. And just like we did in question A, x to the power of 6 times x cubed, x to the power of 3 is 6 plus 3 is 9, so x to the power of 9. And at the back there, hanging around just for fun, is the y to the power of 12. Right, highest common factor. Okay, and we work with big numbers like this. That was too tough. Big numbers like this, it's best to go everything in prime factors, like they've already done the first one with us. Right, so we need to find the prime factors of 540. Okay, you can do a factor tree, or we can do the fishbone method, which I'm going to do here. So we divide it by 2. 540 divided by 2 is, of course, was it 270. We can divide that by 2, which is 135. We can't divide that by 2, but we can divide it by 5. 135 divided by 5 gives us 27. We've now run out of space, but we can divide that by 3, which will give us 9. We can divide that by 3, which will give us 3, and we can divide it by 3, which gives us 1. So, meaning that 540 equals, I'm going to put this in order, ascending order, 2 times 2 times 3 times 3 times 3 times 5. Okay, and that was Q. P, the other number, I don't know exactly what it is, was 2 times 2, 5 times 3 times 3 times 3 times 7. Right, now to find the highest common factor, we need to find the common prime factors. So I'm going to do it like this. Okay, so let's have a close look there. Common factors is 2 and another 2, and no more 2's above there, but then we got the 3's, we got 3 of them, and that's it. So the common factors we have here is 2 2's and 3 3's. Nice. Okay, so what does that equal to? 2 squared times 3 cubed, 108, and that's the highest common factor. Okay, you can always check 540 divided by 108 works, and it's correct. Question C, part 2, find the lowest common multiple. All right, what we're going to do is we're going to take our previous answer, 108, and then we are going to take every number we haven't used. There's a 5, there's a 2, there's another 2, and another 2, and a 7. We're going to use all of that and then hammer that into our calculator. So 108 times 5, and that gives us 30,240. Okay, which is correct. The most common mistake people make here is they think the highest common factor should be a bigger number than the lowest common multiple. But the important part here is factors. Factors is always something divides into, so it needs to be smaller than the original numbers. And multiples is the timetable, so the answer needs to be bigger than the original numbers we're working with. Question 3C, part 3. Now this is the kind of question the examiners put in the exam to make sure nobody gets full marks. Okay, very few candidates got this right, but let's have a look, right? It tells us P times R, and the first thing we need to remember is we already know what P is. They've given us P over there. Okay, P, that's P. Let's write it down. So P was 2 to the power of 5 times 3 cubed times 7. Okay, P needs to be multiplied by something, R, that gives us the answer, which is a cube number. Let's still remind ourselves cube numbers. Cube numbers is anything cubed. So 1 cubed, 2 cubed, 3 cubed, yeah? And then they say R is an integer. Find the smallest possible value of R. So what we need to recognize with cube numbers is they always do the power of, well, cube. Okay, so looking over here, we have a problem. You see that is not a cube number, and there as well, 7 to the power of 1, that's not cubed. We are fine here with 3 cubed, because that will be a cube number. Okay, so meaning to make whatever we have here a cube number, we need to make sure that everything is cubed. So what do we need to multiply 2 to the power of 5 by to make it cubed? Now, if we multiply with another 2, we'll end up with 2 to the power of 6. Is that cube number? Yes, it's a cube number because basically 2 to the power of 6 is 2 cubed times 2 cubed. So that would be cube. Okay, as I said, the 3 cubed is fine, and then 7 to the power of 1, we need to multiply it by 7 squared to give us 7 cubed. Okay, and in the middle we got 3 cubed. That would make everything cubed, everything to the power of 3. So that is it. R should then be equal to 2 times 7 squared. Okay, which is an integer because 7 squared is 49. 49 times 2 is 98. 98 is a whole number, an integer. And that's it. You've done it. Question 3D, part 1, factorizing. The first one is a quadratic expression. And we know that we're going to have to make two brackets, put an x in the first of each, because x times x is x squared. Right, we can try to use the quadratic formula to help us, but I think this will be easy enough. We need to now find two numbers we multiply together to give us minus 28. So what could that possibly could be? 2 and 14, or 7 times 4. Now when we add them together, we need to get the middle term, minus 3x. So 7 times 4 seems most likely to be able to work there. So let's say 7 times 4 gives us 28. We want a negative 28, so one of these numbers has to be negative. So it can either be minus 7 times 4 or 7 times minus 4. Both give us negative 28. Right, now when we add them, we need to get the middle term. All right, so let's see the first one, the second one here. 7 plus minus 4 is 7 minus 4 gives us a positive 3. So that's not going to be it. So it's not going to be the second one here. If we do minus 7 plus 4, yeah, that gives us a negative 3. So that means it fulfills our requirements. So that gives us minus 7 plus 4. All right, let's do a quick check if that is the correct answer. So we multiply it out. X times x is x squared. Yep, we got the first term. X times 4 is 4x. Minus 7 times x is minus 7x. And minus 7 times 4 is minus 28. There we got the minus 28, second term. And when we add these two terms together, we get minus 3, which is the last one. So we know we have the right answer. Just need to put that in there. So it's x minus 7, x plus 4, and those brackets can be in any order. Question 3D part 2. Factorizing again. This time we can factorize out a whole bracket here. Okay. A plus 2b can be factorized out, and inside the bracket we write what's left. So here will be 7. Remember, there is a square, so we still have an a plus 2b and a plus 4a. Now let's just simplify that. They don't say it, but always do to be safe. Simplify things. So 7 times a is 7a, 7 times 2b is 14b, and 7 times, no, don't multiply that last one, it's not in the bracket. Okay, but don't throw it away either. Okay, so it's still there, plus 4a, because now we can add these two terms together. A plus 2b, 7a plus 4a is 11a plus 14b. Okay, and just write the answer nicely on the line. And we've got it. Question 3e. Did they have a lot of fun setting up this question? That is clear. Let's do this. Right. With questions like this, with indices, we want to get the base number the same, which means that 3, we want to get everything at 3. So let's start by, let's write down everything. Let's make that 9 at 3. Now remember, 9 equals 3 squared. So instead of 9, we can put a 3 squared, but don't lose the x. It's still there, times 3 2y minus x. Right. Then we want to get rid of the fractions. So remember, there's a rule of indices that if you've got a denominator, you can write it to the power of a negative. So that's what we're going to do. We're going to have 2x minus 1 equals, and this 3 to the power of 2x, we can write as 3 to the power of minus 2x, and then we don't have any more fractions. Okay, next we can squeeze these two terms together. So remember, when we have two numbers that have got the same base number and we multiply them together, we add the indices together. So we can do that here. So that will be 2x minus 1 equals 3 to the power of minus 2x plus 2y minus x. Okay, so squeeze those two together. Now, brilliant, because we got the two base numbers the same, they're both a 3, that means the indices is equal to each other. So that 2x minus 1 equals minus 2x plus 2y minus x. All right, what is actual our aim here? Our aim is to find an expression for y in terms of x. When you look down here, yeah, put y equals something. So make y the subject. So that's pretty straightforward. We just need to move everything to the other side. So let's do that. Let's move that minus 2x there. So we have 2x minus 1. That minus 2x becomes plus 2x. And let's shove that minus x over as well. So it becomes plus x equals 2y. All right. Let's squeeze all of this together. 2x plus x gives us 5x minus 1 equals 2y. Now we just need to get rid of that 2, which means we divide it. So in the end, we'll have 5x minus 1 divided by 2 equals y. And we can just flip it over, and we have the right answer, 5x minus 1 divided by 2. Question 4, histograms. Brilliant. Right, first thing to remember about histograms is that the class width, let me write this down here, class width. All right, for class width, I'm going to use the abbreviation CW. So here, let's look at this example here. CW, this class width, is 1. That's 1. And the frequency density, which we're going to write FD, okay, the class width times the frequency density, and for this second bar that really is 7, when we multiply that together, the class width times the frequency density, in this case it is 1 times 7, we get 7, which is, there we have it, 7, the frequency. So this is the formula you need to remember, that the area of the bar, which is the frequency, equals the class width times the frequency density. Okay, that is very, very important to remember that. Okay, so now when they ask us to complete this histogram, we need to use that formula. Okay, remember that's FD. So let's have a look. We've done the first one already. Let's go to the third bar over there. So what do we have here? We've got a class width CW of 2 to 4, which is 2. And we want to work out the frequency density. Okay, we want to work out the frequency density. So we need to do frequency divided by class width. So in that case, we are going to do the frequency 15 divided by the class width. So that gives us 7.5. So our second bar over there, okay, goes from 2 to 4, and it goes up to 7.5. So you take your ruler and your pencil, and you draw a nice clear histogram. Okay, if you make a mistake, you can rub it out. Right, you see mine is a bit too low. It needs to be exactly halfway with that bar. A bit too high. Ah, that's perfect. Okay, here we go. Right, second one here. We need to take the frequency, which is 10, divided by the class width here, which is 3. So 10 divided by 3. Gonna give us 3.3 recurring, isn't it? 10 divided by 3. Yeah, 3 and a third, 3.3. So let's have a look. From 4 to 7, we want to go up to 3 to 3. Okay. And the last one there, we got a class width of 5. Frequency is 4, so 4 divided by 5 gives us 0.8. There. Make sure it looks nice and neat with a ruler and a pencil. Question 4a, part 2. We need to calculate an estimate of the mean mass of the parcel. So we need to go back to our table here. To calculate the mean, we add up everything there is. and multiply it by how many there is. Okay, so what is everything? All the weights of the parcels. We need to add up all the weights of the parcels and divide it by how many parcels there is. Only thing is, here we don't know the exact weight of the parcels. We know there's 4 parcels to start off with a weight between 0.5 and 1. Now, because we don't have the exact, we're going to do an estimate. We're going to use the midpoint, right? In this case is 0.75. Okay, so if there's 4 parcels, that is roughly 0.7 kilogram. We're going to have to multiply it together to get that weight. Okay, and show every step of your working out. And we continue with that. The next one, there are 7 parcels between 1 and 2 kilograms. That means our estimate is that they weigh 1.5 each. So it's 7 times 1.5. Next group, between 2 and 4, average weight of 3. So there's 15 parcels that we estimate weighs about 3 kilograms. 10 parcels between 4 and 7. If you're not sure what the midpoint is, add the 2 values together and divide it by 2. So 11 divided by 2 is 5.5. So the middle between 4 and 7, 5.5. 10 parcels between around about 5.5 kilograms. And the last one, 7 plus 12 divided by 2 gives us 9.5. So the midpoint there is 9.5. 4 parcels, about 9.5 kilograms. All of that needs to be divided by how many there is. Okay, so for this, we can add up the frequency, or we can just read the question carefully. There were 40 parcels. So we divide that by 40. And then we put that into our calculator. Right, I put it into my calculator and I get the answer 3.7875. First thing you need to do is check, does this make sense? 3.7875, where would that be in my table? 3.783, that will be somewhere around here. It will be in this group, which is in the middle, which is the mean, is an average, somewhere in the middle. So that means my answer could most probably be correct. Okay, but there's nothing wrong with going through that calculation more than once to make sure, because it's very easy to press the wrong button, a plus when a minus, or put a number in wrong. So double check it. Okay, round it to 3 significant figures, 3.79. Question 4A, part 3, probability. It says a parcel is picked at random from 40 parcels. So there we go. We already know that it's going to be out of 40 total. Find a probability that this parcel has a mass of 2 kilograms or less. So we look on our table there. 2 kilograms or less is everything this way. There's 4 plus 7. There is 11 parcels to pick, to select there, possibly. So it is 11 out of 40. Question 4A, part 4. This one we need to look at carefully. There's a lot of mistakes that can creep in. First of all, we're picking 2 parcels at random, which is not replaced. All right, and we're only picking them from the ones with a mass greater than 2 kilograms. You see that is in bold, and even though that's in bold, many students in the exam ignored that. So what does it mean? It means, we have to jump back here, we are taking from these parcels only all the ones with a mass greater than 2 kilograms. That means if we add the 15, the 10, and the 4, we're picking from a total of 29 parcels. Okay, now even to make it a bit more complicated, we're doing it twice, not just once. We need to work out the probability that one of them has a mass greater than 7 kilograms and one has a mass of less than 4. So let's go first, right? Let's imagine now there's a bunch of parcels and we pick one. The first outcome we want is one with a mass greater than 7 kilograms. We take that parcel, right? That parcel should be one of these 4 parcels. The probability of picking that is 4 out of 29. Let's write that down. Jumping around. So that's 4 out of 29 picking that one parcel. We keep the parcel. We don't put it back. we now pick another one. Okay, now think, we've got one parcel with us, so there will only be 28 parcels left to pick from. And that parcel, the second one we want to pick, needs to be less than 4 kilograms. So it needs to be one of these 15 ones. And they're still all there because the one we picked was from the other group here. All right, so that means it's now 15 out of 28. Okay, next, remember both of these things needs to happen. So that's the and rule. The one and the other, that means we multiply them together. Okay, so let's do that quickly. Okay, that gives me 15 out of 203. But we're not finished. Okay, because there is another thing that could happen, and this is often forgotten. This could have happened the other way around. Okay, we could have sat there and picked a parcel first from the 15 that is less than 4 kilograms. Then there would still have been 29 parcels. And then we could have picked 4 from the ones that is more than 7 kilograms, and there would only have been 28 parcels left. Okay, but the answer to this would be the same, because at the bottom we'll do 29 times 28 and the top 15 times 4. So the results probability of that would be the same, but we're doing it the other way around. Okay, now these two things cannot happen at the same time. Picking the 7 kilogram and then the 4 kilogram, or picking the 4 kilogram and the 7 kilogram. We do the one or the other event. Okay, so in this case, it's the OR rule, so we need to add together these two probabilities or multiply it by 2, whichever you prefer. So the two possible outcomes needs to be added together, which gives us 30 over 203. Okay, can it be simplified? Check quickly on your calculator. If it can be, it will simplify it for you. But nowhere does it say it's right in the simplest form, so that should be enough. 30 over 203. Question 4b, box and whisker plots. First one, find the median. As you know, the median is, of course, in the middle line in the box. Okay, the biggest mistake students make here is reading the scale wrong. It is not 4.3. That would be wrong. Look carefully. There is 5 squares between 4 and 5, so each square counts 0.2. Count them up. 4, 4.2, 4.4, 4.6, 4.8, 5. So the one we're looking at there is 4.6. Okay. The interquartile range, okay, not the range. The interquartile range goes from the lower quartile to the upper quartile. Okay, so the lower quartile being 3 and the upper quartile being just above 6, that's 6.2, not 6.1, 6.2. We need to subtract them, that gives us 3.2. Last one there, part 3, 2 parcels are removed from the van at the first delivery. The masses of these parcels is 2.4 and 5.8. So let's have a look, where does that lie? 2.4 and 5.8. 2.4 will be over there. It's a parcel of this weight, that's 2.4, and the other parcel 5.8, okay, would be around about here. Okay, then the thing to notice here is where they lie. The question is, what happens to the median? Okay, now if you remove a parcel that is lighter, okay, the median will shift. It will go a little bit higher, but then you remove a parcel that is heavier, the median will shift back again. So the answer they're looking for is the median will stay the same. Okay, that's the answer. And then the reason is because one parcel is heavier and one parcel is lighter than the median. The median. There you go. Question 5, column vectors. First one, subtract vector B or vector A from vector B, and this is quite straightforward, but again I'm gonna explain to you exactly what we're doing, so this might take a little bit longer. Right, first thing we need to remember, of course, is that for all column vectors that the number at the top tells us how we go vertically. If we go to the right, of course, it's positive. To the left is negative. The number at the bottom tells us how much to move up and down. Up, of course, positive. Down, negative. So let's start with this vector here, b. Vector b is a vector of 2 over minus 5. That means that if we start somewhere, we need to move 2 spaces to the right and 5 spaces down, and it would look like that, right, in that direction. 2 to the right, 5 down, we move from one point to the next. Then we need to subtract from this vector a, which is minus 3, 8. So it means starting at the same point, we need to move in the opposite direction. A vector a would look like this. 3 spaces to the left because it's minus 3, and 8 spaces up because that is positive. So it's in the opposite direction. So when we subtract them, we get the final vector, which is from where we finish at the beginning to where we go in the end. And that vector would be from there, from the bottom right there, 5 spaces to the left and 13 spaces up, which gives us a vector of minus 5 over 13. Okay, now we don't have to draw all of that in the exam. All you really have to do is write down the vector, 2 minus 5, subtract from that vector a minus 3 over 8. So 2 minus minus 3, 2 minuses makes a positive, so it's 2 plus 3 is 5, and minus 5 minus 8 is you move your minus 5, you move down the number line, 8 spaces gives you minus 13, just like I've shown you. Okay, same with the next one. Right, let's write down vector A is minus 3, 8. And from that, we are adding to it vector B, which is 2 minus 5. First thing we do here is we're doubling the first vector. So what the length is becomes double. So that will give us 2 times minus 3 is minus 6. 2 times 8 is 16. And to that, you add 2 over minus 5. So minus 6 plus 2, we're a minus 6. We got 2 up the number line. That's minus 4. And then 16 plus minus 5 is 16 minus 5 is 11. And you've done it. Question 5a, part 1c, asks you to for the magnitude of vector b. That is what those two lines mean. It asks for the magnitude. How long is the line? How big is the vector? And is also referring that to the line always being a positive value. So let's see how that looks like. All right, so if you look here, if we start at the red dot, vector b is 2, so it's 2 spaces to the right, and minus 5 means 5 spaces down. That means the vector looks like that. Now, if we were to draw a line, make a right angle triangle out of this, we can do it like that. Yeah, draw a line there, draw a line there. I now have a right angle triangle, and I know that this space is 2 and that space is 5, or rather minus 5, like we went down. But it doesn't matter if it's negative or positive, because when we have this right angle triangle, we use Pythagoras to work out the hypotenuse here, which is also the magnitude. We are going to square the numbers, and when we square a negative, it becomes positive. So on our paper here, we are going to write the magnitude of b equals the square root, and then we just take the two vectors, 2 squared plus, if you do put the minus, make sure you put it in brackets. So on your calculator, it looks like this, 2 squared plus bracket negative 5 squared, okay, which will give us square root 29, which is 5.385, etc. Rounded to 3 significant figures. 5.39. Just a quick show you what happens if we don't put that negative into brackets. Well, then we get a negative 25, which is wrong. Okay, because it only squares the 5. We need to make sure we square the negative as well to get a positive 25. Question 5a, part 2. A plus kb equals 13 over m, where k and m are integers. Integers, remember, whole numbers. Find the value of k. Let's write down what we have. We got the vector of a up there, minus 3 over 8. So let's write that down. We write minus 3, 8. Then plus k, the vector of b. We got it over there, 2 over minus 5. And that equals 13 over m. Okay, so now we know, let's take a different color, that if we take this minus 3, add it to k times 2, we should get equal to 13. So that can give us an equation. Let's write it down. So we got negative 3 plus k times 2, or 2k, equals 13. Okay. Immediately what I notice here, we can solve k. We can find out what is k. So if we add 3 to both sides, that gives us 2k equals 13 plus 3. So 2k equals 16. And then we divide the 2. 16 divided by 2, k equals 8. Brilliant. Got the value of k. Okay, now we do the same we did before. We can know that the 8 plus the k times minus 5 should give us m. So we can write that equation down. Let's write it down. So that will be 8 plus k times minus 5 is minus 5k equals m. Now remember, a plus and a minus is the same as a minus. So we can change that to negative. Right, we know what is k. That is 8. So it gives us 8 minus 5 times 8 equals m. That gives us 8 minus 14 equal m. So m equals negative 32. And we've done it. Well done. Question 5b. Now we will move from column vectors to straightforward vectors. And again, each piece of information is very important. First, OABC is a parallelogram. That is an important piece of information because we know parallelogram, opposite sides are equal, opposite sides are parallel. Okay, so with vectors, when a vector is the same length and it goes the same direction, it is the same. So meaning if this is P, this is P, since it's the same length and it goes in the same direction. If this is Q, then this is Q because it is the same length and it's parallel, it goes in the same direction. Right, M is the midpoint, so we know OM and MB is the same length. N is the point on AB such that AN to NB is the ratio 3 to 2. So if we write that down, the ratio is 3 to 2. Think about this carefully. If the ratio is 3 to 2, it means we have divided that line into 5 parts, and this part, AN, is 3/5 of the whole line, and BN is 2/5. So we can say BN is 2/5 Q, and AN, so NB is 2/5 Q, and AN is 3/5 Q. Okay, that is all the information we can get from reading the information at the top very carefully. Okay, so let's start answering the questions. 5b, part A, in terms of PQ, find OB. So OB is this vector here. So going in that direction. We need to follow a path that we know. The most obvious there would be to go right and up, or up and right. So we do Q plus P because we're going in the same right direction, or P plus Q. Any one of those is correct. P plus Q, Q plus P, same thing. Question 5b, part 1b, CM. CM is a vector going from there to there in that direction. Okay, again, we follow a path that we know. We can go from C to B to M, or we can go from CO to OM. I'm going to go from CO and then OM. Okay, when it becomes more complicated, write down the path because you can get marks for that. Now, CO goes in the opposite direction of that vector, so it's negative Q, and OM is half of OB, which we worked out before in the previous question, so it's a half Q plus P or P plus Q, to keep it alphabetically, doesn't matter, right? In the simplest form means we need to simplify that, so that gives us a half Q plus a half P plus a half Q. Okay, final answer here, half P stays a half P. And then negative 1 or negative 1Q plus a half gives me a negative half Q. Okay, one of the many ways to write it down. On the mark scheme, you can also write a half bracket P minus Q or P minus Q divided by 2. They are all correct. Question 5b, part 1, C, vector Mn. Okay, let's look at our sketch there. Mn starts at M, it goes to N in that direction. Okay, again, we can follow a path we can go down the bottom from M to O, from O to A, from A to N, but the shorter path here would go from M to B, and then from B to N. So let's write that down first, right? I'm going to go from M to B, and then from B to N. Okay, so first that MB. Let's write that down properly. Mn equals from M to B to N. Right. Let's have a look. So MB, we already know that. That is half of that line OB, which we got in question A, which is P plus Q or Q plus P. So again, we're going to have half P plus Q. All right. And then BN, as we determined earlier when we went through the information carefully, Bn is 2/5 Q. Be careful now, remember, because 2/5 Q goes in that direction, so we're going in the opposite direction, so it's going to be minus. So let's change that. Instead of adding, we're going to be subtracting 2/5 Q. Right, then we just need to simplify that. That gives us a half P multiplying out this bracket plus a half Q minus 2/5 Q. Okay, so the half P will stay a half P. There's nothing to add and subtract. And then a half Q minus 2/5 Q. Let's not waste our time. Do a half minus 2/5 on your calculator. Bam, 1/10. So it's a positive 1/10, 1/10 Q. We got the answer. Okay, on the mark scheme, also it tells us you can have 5 P plus Q divided by 10. That's another point. Same thing, equivalent. Either one is correct. Question 5b, part 2. Now, here comes trouble. Reading the examiner's report, it says only a very small number of candidates gave a fully correct answer. This is not something that's easy to explain. Again, this is one of those questions they put in there if they don't want everybody to get full marks, right? Or anybody to get full marks for that matter. So what I'm first going to do is I'm going to draw what the explanation tells us. So let's draw that. Let's start on red. It says they extend line CB. Okay, so let's do that. CB, extend line CB. We do that first, and extend line ON so that they meet at point D. then give the position vector of D, which means we need to start at O and give the vector that goes straight to D. Okay, the best way I think for me to explain this is using a similar triangle. So I'm going to redraw that triangle, which I now have in red. I'm going to draw that triangle again as neatly as I possibly can and on its side. Okay. So here I have drawn the triangle COD, and along the line and a point there lies point B and point N. I'm also going to draw the smaller triangle. Let's do that in purple. The triangle BND. There, that triangle BND. Draw it over here. This is the triangle BND. In these triangles, the angles are the same. Okay, because these lines here are parallel, it means this angle B is the same as angle C, or the angle B is the same as angle C. Angle at N is the same as O. You see that angle there at N is the same as angle O there. And angle D is angle D. Okay, this means there are similar triangles. What else do we know? So we know that BN, this one here, is 2/5 of Q. That means Q was going from O to C. That is Q. Okay, so the smaller triangle is 2/5 of the bigger triangle. You're following. So that means that BD over here is also 2/5 of what? Of this whole line going from C to D. Okay, from C to D, dB is 2/5 of that. So we can say this is not 2/5 of P, this is 2/5 of CD. Okay, let me show you what that means. If we were to divide the whole line CD into 5 parts, then BD is 2/5 of that line. Okay, now what else do we know? We know CB is P. So we know this is P, but it stops there at B. So when we divided that line CD into fifths, we've divided the vector P that goes from C to B into thirds. So that's a third, that's a third, that's a third. These are all a third of P. So when P gets extended, we go another third. Okay, remember these are all P. A third P, a third P, a third P, another third P, and another, goodness me, third P. So finally, okay, the line CD is 1, 2, 3, 4, 5 thirds P. So now we can write our answer here. Okay, let's pick a nice color. There we go. So it's going from O to D in that direction. We follow this route where we have Q plus this route, which we have P plus another 1, 2/3 of P, or in total 1, 2, 3, 4, 5 thirds P. So our final answer here, okay, is Q plus 5 thirds P. Okay, I hope that makes some kind of sense doing your diagrams. How are you going to write this? Okay, I would start off by showing a clear path. This path here plus that path there. So that would be writing, okay, to show them that you know what it is, the position vector D, we write as from the origin D, from the origin to D, is following the path OC plus CB plus BD. Okay, that shows whoever marks exam, you've got a clear path. You understand the origin goes from O to D, and you've got a path that you follow. Then you show that I know OC equals to Q, CB equals to P, and here is the part that you need to show that you know, understand that BD, or there, is 2/3 of P. 2/3 of P. And then when you add it together, of course, it will give you Q, and 1 plus 2/3 gives you 5/5. Yeah, gives you 5/3, or 3/3, just B. Okay, look at this again. I know it's difficult, but you can do it. Question 6, triangles. Triangles means trigonometry. Now, if we have a right angle triangle and we're working with the sides, we know we use Pythagoras. If we got a right angle triangle and we're working with angles and sides, we know we use SOHCAHTOA. But if we don't have a right angle triangle and we need to work out sides and angles, we know we need to use either the sine rule, oh my goodness, the sine rule, or the cosine rule. All right, and these you need to learn. Sine rule, sin over A, sin over B, sin over C, or the other way around. Or the cosine rule, A squared equals B squared plus C squared minus 2BC cos A, or the rearranged version. Okay, so let's see what are we going to use here. Right, we got the quadrilateral ABCD made from two triangles. Show that BD is 16.9 meters. Right, which one are we going to use? First of all, the sine rule, I always look for one thing to know if you use the sine rule, and that is you need an angle and the opposite side. So for example, you need to have angle A and lowercase a of angle B, lowercase b, or angle C and lowercase c. Let's see if we got it here, right? We have angle A and we don't have angle B. We need to work it out. We don't have angle B. We got 19, so we don't have those opposites. We don't have angle D in the opposite 60 meters, so we can't use the sine rule. So it's going to be the cosine rule. Okay, and this you need to memorize, okay? Okay, cosine rule, A squared equals B squared plus C squared. Easy, that's Pythagoras. Minus 2BC, and then cos A. Okay, you don't have to memorize every version of that. Okay, so we are working out angle BD. Right. So lowercase means the side. So we can relabel this BD as A. That's the one we want to know. Okay. So I'm going to write A is BD. Okay. And to save time later on, I'm going to move this square to the other side already. That means we're going to square root everything. Now B and C doesn't matter. In this case, we can make 19B because it's opposite B. That's 19 squared. And even though this is angle D, we can relabel it C. But if we swap those two around, 16 and 19, it doesn't matter. Then it's minus 2, B is 19, C is 16, cos, and A would be 57. Right. Now we just need to put that into our calculator. And here we go. Square root of 19 squared plus 16 squared minus 2, 19, 16 cos 57. Close the bracket. Make sure that line at the top, the square root extends all the way. And we got an answer. 16.907, etc. Rounded to 3 significant figures. Okay, and this is important. Show your unrounded answer. Okay, because you get a mark for that. Rounded, it gives us 16.9 meters, and that is what we were looking for. Question 6b. We need to find angle CBD. So let's go back to our diagram. Angle CBD. CBD is this angle here. Now, from the previous question, we know that this is 16.9. So, and we know we're not going to use Pythagoras or SOHCAHTOA. We're using the sine rule or the cosine rule. All right. As I said before, for the sine rule, we look for opposites. Right. In this case, we have very clear opposites there. We got this angle 75, and we got this opposite side 32. That's a clear indication we are going to use the sine rule. Okay, so let's write that down. The sine rule has, of course, two versions. There's the version where we put the side at the top and the angles at the bottom. Or we can do it the other way around. We can put the angles at the top and the sides at the bottom. What do we want to know? We want to know this angle here. And the best advice I can give you, always put at the top the thing you want to know. So we're going to use the second version here. Okay, that's the one we're going to use, because the unknown is going to be placed there, which is the best place. So sin CBD is the angle we want to know, over the opposite side there, which we do not have. Okay, but I have this side here. That means I can work out that angle over there. Okay, this is angle BCD. So I'm going to do that. So let's change what we were doing. I'm now working out angle BCD. This one over here. Okay, the opposite side to that angle is 16.9. I'm going to set that equal to sin any other angle I know, and this is this one here, 75 over the opposite side there we have 32. All right, the reason now we got the unknown there at the top left-hand corner, because now working it out is quite simple. We need to multiply the 16.9 over there. So sin BCD equals 16.9 times sin 75 over 32. Let's work that out. Okay, fraction 16.9 times sin 75, close the bracket, over 32. Okay, and we get an answer which is obviously not our final answer. Where shall we write this down? I'm gonna use some space down below here. Okay, because we still have sin BCD. Okay, do not round your answer yet. Okay, so for BCD, I now need to move the sin across, so that's sin to the power of minus 1, 0.5101, etc. Putting that into my calculator, press shift, sin to the power of 1. I can insert my previous answer, so I don't use a rounded answer. My answer is more correct. And press equal. And I got an answer now. Angle BCD equals 30.672. Now remember, this is not my final answer. I've solely now worked out angle C here, 60.672, etc. But we can now, using basic angle rules, find the angle we want, which is the one up here, by doing angles in a triangle. So my next step will be, oh my goodness, run out of space, 180 minus angle BDC, which is 75, and the one we just worked out. Okay, so 180 minus 75 plus, again, insert my previous answer, and there we go, 74.327, rounded to 3 significant figures, 74.3. Question 6c, find the area of the quadrilateral ABCD. So what we recognize here, we got two triangles. We need to work out the area of the triangles, add them together. Usually we would use area of a triangle is half base times perpendicular height, but we don't have the perpendicular height here, so we're going to use the other formula, which is half AB sin C. Right, so let's start with the triangle ABD, and we're going to write that down. Okay, triangle ABD is half, right, what is A, what is B, and what is sin C? To be able to use this formula, we need two sides. We can label these sides ourselves. Let's make that AB in sin C would be then the angle in between. So for there's two sides and the angle, the included angle between those two sides. So our A and B is 16 and 19, and our C will be 57. All right, so to relabel the triangles in such a way that you are comfortable. All right, so our A was 16, our B was 19, and our C was 57. Okay, and all we need to do now is type that in. So it's a half, 16, 19, sin 57. And we get an answer, 127.477. Put lots of digits down rounded. Okay, our next triangle will be triangle BCD, the triangle on the right. So that's a half. Again, we're looking now for AB sin C. So to be able to do that, we need two sides and the angle in between. So we can label these sides any way we want to. We can make this one A and that one B, or the other way around, and the angle C will that be that one. All right, so in my case, I've got 32, 16.9 was the other side, send the angle we just worked out. What was that again? 74.3. Let's put that in. And we get an answer. Right, the next step would just be to add these two answers we had before together. Okay, 127.477 plus 260.311. That gives us 387.788. Rounded to three significant figures, 388. And we've got it. Question 6D. Find the shortest distance from B to AD. So let's first look at that distance. What do they mean? From B to AD, the shortest distance can only be one thing, a perpendicular right angle line. Okay, so we want to know this distance here. Immediately now we've got a right angle triangle. Great, we mentioned that before. And in that right angle triangle, we've got an angle and we've got a side. So we're going to use SOHCAHTOA. Okay, let's label our triangle. 16, of course, is the hypotenuse. And opposite the 57 is the one we want. So that will be the opposite. Working with the opposite and the hypotenuse, we're using the ratio so. So it's going to look like this. Okay, we're using sin. That angle is 57 degrees equals the opposite, which in this case is AD over the hypotenuse. What was that again? 16. Okay, so all we need to do now is multiply the 16 over there. So in our calculator, it'll be 16 times 57 will give us AD. Let's put that in. 16 sin 57. And we get AD is 13.418, etc. Rounded to three significant figures, 13.4. Question 7a, transformations. The first one, translation by vector 2 minus 1. Now remember with vectors, the top number tells us left or right. So we're going to have to move to the right because it's positive. And the bottom number tells us up or down. We're going to move down because it's negative. Right, and we're doing triangle T. So make sure you have your piece of tracing paper in the exam. Ask for it if you don't have it. Okay, trace that triangle nicely. Right, translation vector 2 over 1 means we move 2 spaces to the right and 1 space down. That's where we are. Mark the points clearly, the corners. Then use a ruler and a pencil to draw your new shape clearly. And you're done. Question 7a, part 2. A rotation of 90 degrees about the origin. Now the origin, of course, is the point 0, 0. 90 degrees clockwise. Put our pencil there in the middle. Clockwise is in this direction. And we do a quarter of a turn until we fit nicely. Okay, again, mark the corners. And use a pencil and a ruler to draw it. There you go. If you're not sure if it's 90 degrees, connect a corner, and connect it again, same corner. There we go. That's a 90-degree angle. Question 7a, part 3. A triangle T after enlargement, scales factor minus a half, center minus 2, 3. So let's start with that minus 2, 3. Minus 2 along the corridor, up the stairs. There is our center of enlargement. Okay. A scale factor of a half means, of course, our shape is going to be half the size. And that negative, that doesn't mean it gets smaller. It means our enlargement is going to be on the opposite side of the center of enlargement. So let's see what that's going to look like. Let's start with the right angle corner here. To get from the right angle corner to our center is 2 squares down and 1, 2, 3, 4, 5, 6, 7, 8 squares across. Okay, now on the opposite side, we need to half that. Okay, so instead of going 2 squares down, we go 1 square down. And instead of going 8 squares across, we go 4 squares across. And there we go. That's where the new corner is going to be. Let's do the same now with this bottom corner here. Okay, to get from there to the center, we move 1, 2, 3, 4 squares up and 8 squares across. So from the center, instead of going 4 up, we now just go 2 up. And instead of going 8 across, we go 4 across. Okay, this makes sense because it's in line with the previous point like it should be. And this triangle is 6 squares high. Now it's only 3. So we know we're on the right track here. Okay, last point. Okay, draw a line through the center of enlargement there. Okay, to get from this point to the center, again, it's 2 squares down, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 squares across. So from the center again here, instead of going 2 down, we go 1 down, and instead of going 12 across, we go 6. 1, 2, 3, 4, 5, 6. Okay, and you'll know it's right when it looks right. Okay, it looks right to me because my triangle is half the size and it's flipped over on the other side, which means it's negative. Question 7b, describe fully the single transformation that maps triangle T onto triangle A. Now the first instinct here is to think it's a rotation. Okay, but if you rotate it, you see the orientation just is not right. Okay, so there could only be one other thing, and that's a reflection. Okay, because it's flipped over. Okay, reflection, got a mirror line, and when you look in the mirror, things flip over like that. Okay, so that's the first thing we need to write. Because on the line here, describe, so right, it is a reflection, 1 mark, and a reflection, of course, has a mirror line. In this case, the mirror line would be a diagonal. Looking like this, let's go from 6, minus 6 to minus, yep, it will be looking like that. See that? We can now see that each corner is connected with exactly the same distance, right? You don't have to draw these lines. This is just to show you that the distance from the right triangle to the mirror line is perpendicular, and it's the same distance on the other side, each one of those. So the equation of this line, of course, a diagonal line is y equals x, but y equals x is a 1. Diagonal line goes like this. This is y equals minus x, or minus y equals x. And you've got it. Full marks. Question 8a. Examiner's report says majority of students did find this difficult, but if we go slowly, look at every piece of information, we can do it. A cuboid has a length L, we can see that, with a width W and a height H. The diagram shows the net of this cuboid. We can see that the ratio of W to L is 1 to 2, so let's remember that for when we need it. Find the value of L, and the value of W, and value of H. All right, the first thing I've recognized here is we can write an equation. Okay, let's start horizontally. This length here, L, okay, would be, not 4L, would be the same as this one. This would be the length of the cuboid from there to there. Okay, then as we fold the cuboid, this side H would fold onto this one. So again, here we have another H. So this will also be H, that length there. And again, if we fold it, this would also form H. All right, so when we fold it, we'll have those lengths. That means if we add up all the horizontal lines, there is 2 L's, well, there's 2 H's, and there's 2 L's. That will be equal to the whole length of the net here at the bottom, 37.8 centimeters. Okay, now vertically, we can do the same thing. We can look at what we have here. Okay, again, we've got the W. We want this length here, which if we fold it, will give us another H. Okay, so this one and that h is the same. So for the vertical line, if we add up the two h's, the two heights, plus the w, it will give us the vertical height of the net 20.1. Okay, we're making good progress. We're picking up some marks already. Okay, now this is not quite simultaneous equations. Of course, with simultaneous equations, we got two unknowns, but here we got three. We got h, w, and l. And we were going to subtract these two equations now. It's not going to work. We can maybe eliminate the h, but not the l. We can't subtract the w from the l. But we do have one other piece of information. Okay, that's always, if we get stuck, go back to what they tell us. We haven't used this piece of information yet, the ratio. The w to l is 1 to 2. That means if we want to know what L is in terms of W, we need to multiply W by, not by 3, oh my goodness, by 2. So 2 W's equals an L. Yeah? W is half of L. 2 W's makes an L. So that means what we can do now, we can change this L in the first equation. We can swap that for W. Okay. So that would mean, all right, let's write this in. So 2L, that 2L there will equal 2, and we substitute the L for 2W, so 2L is 4W. So let's write that again. We got 2H, write that equation here, plus 4W equals 37.8. We could, of course, change this W here for half an L. That would also work. Okay, I'm just going to write this equation again, the second one. So we got them nicely lined up. And now we've got simultaneous equations, and we can eliminate one. In this case, it's straightforward. We subtract the one from the other because 2h minus 2h is 0. We've eliminated the h's. 4w minus w, 1w gives me 3w. And 37.8 minus 20.1 is, of course, 17.7. Then we divide that by 3, and we have w, 5.9. Okay, things are looking good. So now we know that 2 W's gives me an L, so 2 times 5.9 will give me, times that by 2, 11.8, which is L. Okay, let's write down what we got here. Okay, so we got W is 5.9, L is 11.8. Now justify H, and for that we can use any of the equations up there. I'm going to use this one. The second one I wrote there, just because it looks the most straightforward. 2h plus w, which we had is 5.9, equals 20.1. So 2h means we got 20.1 minus 5.9. Okay. 14.2. Divide that by 2, gives me 7.1. And we've done it. Question 8b, there's a lot of information here to go through. Okay, I'll let you do that by yourself. So we jump to the question. The pyramid is made of wood and has a mass of 800 grams. Calculate the density of the wood. Give the units of your answer. That's a lot to take in it now. So we just start with what they give us. All right, to start 1 point, one little thing. There is the formula for the volume of the pyramid. So let's start banging away with that, right? Let's write down the formula. V equals a third times the area of the base. In this case, that will be 18 times 15. So 18 times 15 will give us the area of the base times the height. And there's the height. Do we have the height? No. DE, we need to find that height there. Okay, but do not fear, just look carefully. That forms part of a right angled triangle. So immediately we think Pythagoras, SOHCAHTOA. What do we have in this right angled triangle? We've got the length CE, but also got the length CD, since the base is a rectangle. So we got two sides, of which one is the hypotenuse. All right, that means we can work out DE. Okay, so just to refresh our minds, Pythagoras will be CE squared equals CD squared plus DE squared. Or rather, since we want to find DE, it would be the other two subtracted. So that would be CE squared minus CD squared. And to save ourselves some time, we'll put the square root over there. So now we just need to hammer in the numbers. Okay, CE was given to us, that's 24 squared. And CD is 18 squared. Okay, oh, that's an ugly square. Let's put that in. 24 squared minus 18 squared. Okay, now we can write this very long answer there, but it's a lot more accurate to leave the answer in third form, which is 6 square root 7. That's easier to use, and that will give us a more accurate answer. Okay, so that means now we can work out the volume of that shape. So let's do that. Okay, it's a third times 18 times 15, the area of the base, times 6 square root 7 equals. Okay, I wish we could have written that in third form, but that's not possible. So it's 1428. Don't round your answer. You don't have to write all the digits, just write a fair amount. Okay, I mean 7 significant figures should be good for a good answer. Right, and of course that is the volume, which we've now measured. Volume is in centimeters cubed. Excellent. Okay, we have now managed to use that first formula. Next one, we want to find the density, and they've given us the formula. So density equals the mass, where they've given that to us, 800 grams, divided by the volume. We've just worked that out. Centimeters cubed. Okay, so on my calculator, I'm going to do 800 divided, and I'm going to insert my previous answer by pressing answer. It'll give me the most accurate answer, and that is 0.5599, etc. Okay, rounded to 3 significant figures. Of course, we need to cut it off there. So what comes after 59 is 60. So it's 0.560. Okay. And the units, we got it here. We divided grams by centimeters cubed. So that's gram by centimeters cubed. And that is correct. Question 8b, part 2. Calculate the angle between BE and the base of the pyramid. So let's see what that looks like. This is BE. Okay, and then the base of the pyramid means that's the base. We can draw a diagonal across like that. That's the angle we want to know. Okay, so just to make that clear, let's draw a triangle over here. This is the triangle with E at the top. Down there at D, we have a right angle and B. Let's see what we have in this triangle. At the moment, seems we don't have much. Okay, what can we find out? Oh yeah, we got the height. We worked out the height just in the previous question. And that we used Pythagoras was 6 square root 7. So we got that from the previous question, 6 square root 7. Okay, now if I can find another side in this triangle, we can do SOHCAHTOA. Okay, and for that, I can clearly see, why don't we use this triangle on the base of the pyramid there, where This will be a 90 degrees angle. We got the 15, and across there we know that is 18. Okay, so here we go. Pythagoras. Okay, this is the hypotenuse in this triangle. Okay, so BD will equal the square root of BC squared plus DC or CD squared. Okay, we know that BC is 15, so that's 15 squared, and CD is 18, that's 18 squared. So let's do that. Of the square root 15 squared plus 18 squared. Okay, again, let's leave our answer in surd form because that is more accurate. So going back up here, we now have that hypotenuse that was 3 square root 61. And of course, that hypotenuse now, or the diagonal of that rectangle, is also the base of our triangle there. Okay, so here we go. We got a right angle triangle and we're working with sides and angles. So we're going to do SOHCAHTOA. You just need to label it correctly. The angle here, DBE, this right next to it will be the adjacent. And opposite there, of course, is the opposite. So we're working with O and A. We use the ratio 2R. So let's write that down. We're using tan. The angle we want to know is DBE. Tan is the opposite over the adjacent. Let's just have a look again. The opposite was 6 square root 7. 6 square root 7. And the adjacent was 3 square root 61. So to work out the angle, DBE, we need to move that tan across, which gives us the inverse of that, tan to the power of minus 1, 6 over square root 7. And 3 over square root 61. Okay, let's hammer that in. Shift tan fraction 6 square root 7 over 3 square root 61, side arrow bracket, and we get ourselves the answer 34.117. Just put another one, etc. Okay, which we can round to 3 significant figures. 34.1. And you've done it. Question 9a, part 1, gives us a cubic equation. It can be written in the form y equals x bracket x minus a squared. So just look carefully at that. First of all, we can see that there is a little x factorized in front. So we can do the same here. We can factorize out the a. So from each of these terms, there's a common factor of an x. So we put that in front. Then since we removed one x, that will be x squared. Check your answer. X times x squared is x cubed. Excellent. Factorize an x there. X times minus 4x is minus 4x squared. Excellent. Plus 4 because x times 4 is 4x. Good. We're on our way. Okay. Now we need to factorize that quadratic equation inside the bracket. For that we know we need to make 2 brackets. And it's going to be an x times an x. Okay. And there's a lot of clues over here. Okay. We need to multiply 2 numbers together to give us a positive 4, and that can probably be 2. Okay, there's a minus there, so what would that be? Minus 2 times minus 2 will give me a positive 4. Excellent. And when we add them together, we need to get that middle term, minus 4. So minus 2 plus minus 2 gives us minus 4, and that must be it then. That gives us minus 2 and minus 2, which is 2 brackets. It's the same. That's why we can write it as x minus 2 squared, just like they've got it up there, meaning a is 2, not minus. The minus is already there, just 2. So question 9a, part 2. they want us now to graph this cubic graph. Okay, so remember, a cubic graph normally, this is not the right answer, would be something like this, where we cross the x-axis in 3 places. Okay, so that's what we need to find, where it crosses it. So, okay, let me rub that out so we don't get confused. Okay, what do we have? We got what they've given us, we just worked out, is this. Okay, my goodness, y equals x minus 2 squared, or rather x minus 2 x minus 2. Okay, and we need 3 x values. Now where this graph will cross the x-axis 3 places, there y would be 0, so we can set all of this equal to 0. So actually we can make the y 0. I want to know where it crosses the x-axis, that means y is 0. Now because we multiply all of that together, it means we can break it up. That means x equals 0. Okay, and now we got our first spot. Okay, we know that it will cross the x-axis at 0, and then the next two is the same, so we don't really have to do this twice, but just to bring the point across, we can make x minus 2 equal to 0, x minus 2 equals 0. That gives us x equals 2 and x equals 2 twice. Okay, so that means it will cross the x-axis there. Let's mark the point there. That will be the point 2, 0. We write it down. It's important. We need to show them that we know what that point is. So remember, we're looking for a graph that goes like this. So we know it's going to come up. It's going to go through the center there, turn back down, and now because we got 2 of the same answers, don't make it wobbly. Okay, 2 of the same answers, it's going to touch the graph, the x-axis there, and then go up again. Okay, that's the significance of having the same answer twice. Okay, so make sure everything is clear. Indicate where it goes through the axis at 2, 0, just to make sure. Show it there. It goes through 0, 0, and you'll get all your marks. So indicating the values on the graph where it meets the x-axis. Excellent. Question 9b, it tells us to find the equation of a tangent to the graph y equals s cubed minus 4x squared plus 4x at x equals 4. Okay, give your answer in the form y equals mx plus c. Now that is the formula for a straight line, of course. Let me show you what this actually means. So here I have the equation, the graph of the equation y equals x cubed minus 4x squared plus 4x. Now a tangent to x equals 4, which means we'll have to draw a line that touches the graph at x equals 4. Okay, so this is what that tangent actually looks like. So when we go to where x equals 4, now I have to go all the way up. You see, there's a blue line, touches it there, around there. It's very hard to see, okay, but there we go. Oh, maybe it's better if I zoom out a little bit. Okay, so you see that blue line is the tangent, and at x equals 4 it touches it, so it's a line with a very steep gradient, and it passes the y-axis way down there. Okay, we need to find the equation of that blue line. All right, now to find the gradient on a curve like this at any points, we do differentiation. So let's start by doing that differentiation. Okay, so the gradient is the change in y over the change in x. Differentiating y equals x cubed, we do the 3 times what's in front of the x, which is 1. So 3 times 1 is 3x. Subtract 1 from the 3, that's 2. 2 times minus 4 is minus 8. Subtract 1 from the 2, that's x to the power of 1. The last term there, 1 times 4 is 4. X minus the 1 from the 1, that gives us x to the power of 0, which is anything to the power of 0, 1. So that means we end up with 1 there. 1 times 4 is 4. It stays the same. Okay. Next part is they told us x is 4. So we need to substitute that into our equations. So now we got 3, 4 squared minus 8 times 4 plus 4. Okay. Don't waste time. Let's hammer that into our calculator. 3 bracket 4 squared minus 8 bracket 4 plus 4. Okay, 20. Now remember, that is the gradient. In our general formula here, m, what is in front of the x, that is the gradient. So now we have y equals 20x plus c. That's how much we got of the equation yet. The next thing we need to find is where does it cross the y-axis, the y-intercept. Remember, we saw it was way down low on the graph. Okay, what can we do? How can we do this? Right, we do have one point. No, we don't. We don't have a point on the graph. We only got x equals 4, and we need an x and a y value to put in there, because when we put an x and a y in an equation, we can work out c. Okay, but we can find the y value up here by putting the x into this equation. So that would tell us what is the y value at x equals 4. So let's do that. Okay, we want to know what is the y value when x equals 4. So we substitute all the x's for a 4. So that's 4 cubed minus 4, 4 squared plus 4 times 4. Oh my goodness, look at all those 4s. Right, here we go. 4 cubed minus 4, 4 squared plus 4 times 4. And that gives us 16. Excellent. We now have a coordinate. We've got the coordinate 4, 16. Okay. If you look at the graph again, yeah, if we zoom, yeah, there at 16 and 4, that is exact point there where it touches our graph, even though it's hard to see. Maybe if I zoom in forever, we will be able to see that clearer. But let's get back here. So we now have got an x and a y value, and we can put it into that equation there. So when y is 16, x is 4, that gives me 16 equals 20 times 4 is 80. All I need to do now is subtract the 80 from 16. And what is that? Yes, that looks good. Minus 64. So here we go. There is our equation. Y equals 20x. And the y-intercept, the c value is negative 64. And you've done it. Question 10. Sequences. Okay, we start off easy. Sequence A, you recognize here that these are the cubic numbers. So for example, 1 cubed equals 1, 2 cubed equals 8, 2 times 2 times 2, 3 times 3 times 3, 3 cubed equals 27. Then we got 4 cubed is 64. So of course, 5 cubed, 5 times 5 is 25. 25 times 5 is 125. So here we have n being the nth term cubed. Okay, pretty straightforward. Next one, let's look at the common difference. We add 6, we add 6, we add 6, then we add 6. That's easy, so that's 29. And the nth term rule is n plus 6, right? No, it's not n plus 6. Don't ever please write n plus 6. It's not. Okay, it's 6n because it is exactly like the 6 times table, which goes 6, 12, 18, 24. Differences here. Our sequence is 5, 11, 17, 23. Exactly one less than the 6 times table. That's why you put a minus 1 in front, at the back, I mean. Right. Then the things heat up a little bit with sequence C. Okay. Look carefully here. I'm sure you can recognize that we are multiplying by 2 each time. Okay. So this is a geometric sequence. Now, there are different ways to find the nth term rule for that. For me, the easiest way that always works is to learn the formula. The formula is the nth term rule, an equals a1 rn minus 1. Okay, that a1, that refers to the first term, and the R refers to the common ratio. Okay, so what does that mean? Okay, so easy here. Our first term is 0.25. Common ratio is what does it get multiplied from term to term? That is 2, so the common ratio is 2, and that's to the power of n minus 1, and that is correct. That will get you your mark. Now I know in the mark scheme they have something else. In the mark scheme they've got 2n to the power of minus 3. Okay, and that's also correct. It says there OE in the mark scheme, which means or equivalent. And my answer there is equivalent, and I'll show you why. Okay, 0.25 to n to the power of minus 1. Now 0.25 is the same as a quarter, all right, which we can write as 2 squared. Now if you remember the rules of indices, 2 squared as a denominator, we can write as a normal index exponential when we make it a negative, and then 2 to the power of n minus 1 we can rewrite as 2n and 2 to the power of minus 1, because when we multiply those indices, the base numbers are the same, you add the indices. So 2 to the power of n times 2 to the power of minus 1 is the same as 2 to the power of n minus 1. Okay, next step of course is just we have all the base numbers the same, so we can add it all together. So that's 2 to the power of minus n minus 2 plus n minus 1 simplified is 2 to the power of n minus 3. It's the same. Okay, and you'll get your marks if you wrote what I wrote there. Okay, if you're not happy with that, there's another way. Let me show you. Right, so the moment you recognize this as a geometric sequence, you can write, and as a basic geometric sequence, we multiply everything by 2. Let's write the sequence of 2 to the power of n. Okay, so the first number in that sequence would be 2 to the power of 1, which is just 2. The second number in that sequence would be 2 squared, which is 4. Third number in that sequence would be 2 cubed, which is 8, etc. Okay, the fourth number 2 to the power of 4, which is 16. That's the basic geometric sequence of 2n. Okay, now what do we have here is we got 0.25, we got 0.5, we got 1, we got 2. Okay, now if you look at that difference between those two sequences, okay, look where we have the 2 in this sequence they're given us. Look where the 2 is in that sequence there. It means that our sequence has shifted up 3 spaces. Okay, so it's gone there, yeah. It's now the 2 has shifted 1, 2, 3. There it is. It's gone there. Shifted to the right. Okay, that means 3 spaces shifted to the right means it has gone from 2 to the power of n to 2 to the power of n minus 3. Because now if we subtract 3 from the n there, so 1 minus 3 is minus 2. 2 to the power of minus 2 gives us 0.25, etc. If we look at the third term there, that's 2 to the power of 3 minus 3 gives us 2 to the power of 0. Anything to the power of 0 is 1. That's what we have there. That's another way of finding it, if it works for you. Right, sequence D looks insane, okay? And the secret here is always, if it looks hard, just look carefully at the previous sequences, and you might spot here that it is simply sequence B minus sequence C. 5 minus 0.2, 4.75. 11 minus 0.5, 10.5. 17 minus 1, 16. 23 minus 2, 21. 29 minus 4, 25. And in the nth term rule, okay, we take the sequence B, which is 6n minus 1, and subtract whatever you wrote for sequence C. Even if you got it wrong, if you write there that you're subtracting it, you'll get your marks. And that will give you my full marks. Okay. Or 6n minus 1 minus, let me write it down, 6n minus 1 minus 2n minus 3. That will also get you your marks. Either one is correct. Okay. You can do it. You've just done it. Well done.